beginning of the unit because we did actually solve exponential equations. Now, why would you say that 8 to the x equals 32 is considered an exponential equation? Because it what? Has an exponent with an x in it. So this is an exponential. And we actually solved problems like this using the method of common bases. Do you remember common bases? All right, what is the common base between 8 and 32? What number can I rewrite those? No, 4? It's 2. 2 to what power is 8? 3. So remember, we wrote this as 2 to the 3rd, and then we kept the x the same. And then 2 to what is the 32nd? 2 to the 5th. So then what we did was we multiplied these exponents together, and we have 3x equals 5. So what does x equal? 5/3. Okay, remember doing that? You guys are really good at it. So let's look at the next one. 9 to the x equals 21. What's the common base here? Does 3 to a power give me 21? No. Something else? So this one doesn't work. So we need to figure out, if I can't use common bases, how do I solve that one? And until 30 seconds from in the future, we don't know how to do that. But I'm going to show you a law using a logarithm that will allow us to solve that problem and get the x out of the exponent. So here's the law. One thing we need to know in order to solve these is just have a general understanding of this. What is the inverse of an exponential function? A logarithm. Okay, so think about when we solved another equation. Remember we talked the other day about how if I have x plus 7 equals 13, I have to subtract 7 from both sides because negative 7 is the inverse of positive 7. So we have to use, bless you, inverses to solve an equation. So if my equation, like this last one, 9 to the x equals 21, that's an exponential equation. So I have to use its inverse, which is called a, what's the inverse again? A logarithm. I have to use a logarithm to solve it. So here's the law. It looks kind of mathy. I'm going to tell you a story that will make that rule make sense. There's a lot of logarithm laws. This is the one we're going to do. So suppose you are out. Here's you. And you're playing basketball. So here's your basketball. But you're not just playing basketball. You're playing basketball in the woods. Don't ask me why. You just are. So there's your tree. It's your little basketball hoop. Okay, there. It's great drawn, huh? Should have been an art teacher. So there's your basketball hoop. You're playing basketball in the woods. And have any of you ever shot a basket up and then the ball gets stuck in between the rim and the backboard? Yeah, you've done that. Okay. So there's my backboard. There's my hoop. I shot the ball up. Oh no, it's stuck. And you're in the woods playing basketball all by yourself, and you're thinking, how in the world am I going to get my basketball down from up there? So you're in the woods. What's around you in the woods? Trees. And what falls off of trees? Sticks. Okay, what's a really big stick called? A branch. Bigger than a branch. A log. Right? Are you getting where I'm going here? So you're looking around and trying to get this basketball down, so you pick up a log and you throw a log at it. Now what happens when you throw a log? Here's my log. I threw a log here at the basketball. What happens to the basketball? It falls down. So what we're going to do, so this is my logarithm law. So this little x up here, that's my basketball. It's stuck up there. The only way I move that exponent, that basketball, out is to throw a log at it. So you take the log of both sides, or you'll take the log, and what happens is that exponent comes down, falls down in front. That's where I get this x times the log. So let's see, let me show you how this works. Let me give you an example. So let's visualize it a little bit better than the definition. What's the exponent in a? 2. So with that log in front, I threw a log at it, that 2 comes in front. So it would be 2 times log of x without an exponent. Same thing in b. That 9 is the exponent with the log in front. I'm allowed to move that 9 to the front. And I have 9 times log base 3 of x. So the c is actually how we're going to do things. We have an x in the exponent, and when I have a log, I now have x times log base 2 of 100, and that's really nice because now that x is not in the exponent anymore, which is our goal for things. Yes? Good? Okay, so let's see this log rule in action. Let's solve the equation. 5 to the x equals 8. Now, could you solve this using common bases? Is there a common base between 5 and 8?
No.
No. So now, if I can't use common bases, I'm going to use my log rule. So here's what the steps are. Take the common log of both sides. So throw a log at it. So you're going to write log of 5 to the x equals log of 8. So once I threw that log at the problem, what happens to the x? It goes in front. It comes down. So what you have now is x times log of 5 is log of 8. Now, how do you think you isolate the x? Divide by log of 5. Okay. So you get x equals, now you can take out your calculator. Don't do anything with your calculator until the last step. Now, be careful when you do this, though, log of 8. Make sure you close the parentheses after the 8, otherwise your calculator will read things wrong. So you do that, divided by log of 5, hit enter, and that would be your value. Now, typically in this unit, we're going to round things to 3 decimal places, the nearest thousandth, unless it says otherwise. So what's the answer here? 1.292. Good. And what we found here, how could you check your answer if you wanted to? Yeah, you can put that in for x. So if I took 5 to the 1.292 power, it's pretty much 8, right? There you go, you found it. Not hard? All right. They're not going to be too bad today. They will get yucky next week. But today, they're not so bad. So what is the log with a base of 10? Common log. So we're going to use just the common log for now. So this guy, this common log, because he's common to everybody, can work no matter what the number. So let's try a couple of these here. So in A, can I find a common base between 5 and 18? No, so I have to use logarithms. We're going to do the same thing. I'm going to take the log of both sides. And you can start, I'll do this probably on the next one. You can start skipping steps if you need to. If like you automatically want to drop that x in front and just write it as x times log of 5, you can go ahead and skip right to that step. I tend to do that when you look at my answer. So don't feel like you have to write every step down if you've seen it here. All right, then to isolate the x, we divide by log of 5. And I'm going to write it up above so I don't run out of room. What is log of 18 divided by log of 5? Is that what other people got? Yeah. Okay. So it might seem like all these kind of look the same, but they're actually all different. So we'll look at the next one. Does 104 have a common base? Do 104 have a common base? Yeah. Okay, what would it be? 2 to what power is 100? Not that big. There's actually not. It's not 2 to anything. It looks like it. Like you can it's divisible by 4, divisible by 2, but neither of those have a common base. So we can't use common bases here, so I can still take the log of both sides. So take the log of 100, and I'm going to skip right to this step, x times log of 4. If you need, you can write out the other step. And we know the x is going to come down, so we can skip right there. Now, before you move on, I want to try to show you some ways to simplify your life here. If you ignore the fact that we're in an equation, and I looked just at log of 100, if that was on your warm-up slip, I think there was a similar one on your slip today, what would you say log of 100 is? 2. If you recognize that, because it's log base 10 and 10 to the second is 100. If you recognize that it's 2, you can write 2 down. If you don't recognize that it's 2, that's okay. You will just do the same thing as usual. It'll give you the same answer. You'll just have a little bit more writing to do. But if you recognize log of 100 is 2, you can do that. Now, you could probably simplify any log that's the number is a multiple of 10. So log of 10, log of 100, log of 1,000, log of 10,000. You could simplify all those. So the only thing you have to do left is divide by log of 4. So go ahead and find for me. What's 2 divided by the log of 4? 3.322? All right, last one here, and then we're going to make a connection. 216 to the 30 equals 36 to the x. Can I use a common base? Yeah, I can. It's 6. So if you see that you can use a common base here, use it. It's probably faster. If not, go ahead and take the log. So 6 to what power is 216? 3. So 6 to the third. And 36 is 6 squared. So that gives me 3 equals 2x. And what's x? Okay so far? Now look at your answers on this page. I know one of mine's kind of hiding up here. 1.7. There was an answer. Which of these, A, B, or C, gave me a rational answer? C. What method did I use to solve that? Common basis. When I look back up at the top, the very first thing we did was the answer for A up here, rational. Yeah. Now if I use a logarithm, so this problem and the next two, then I get rational or irrational answers. Irrational. So, this is just so you know, if you solve something and you get a rational answer, you could have used common base if you did like a log. Alright, you don't have to. It really doesn't matter what method you use. You can use a log for it or common base. But sometimes these common base ones are easier, and you'll always get a rational answer if you use common bases. Cool? Alright, I think it's time to flip your page. Can't remember, is it? Yes? Okay, now these ones just look slightly yuckier in the exponent. So here I have 2 to the x. So can I take a common log or a common base of 1.03 and 2? No, so let's take the log of both sides. So that whole exponent, 2x, is going to drop down the front. And you'll have 2x times log of 1.03 is log of 2. Now the reason I'm showing you this one, even though you might think like this is not that much harder, is there's actually an order that I think is best to solve this. And that would be to do all of the log stuff first. Don't touch this exponent guy until I move the log. Get all the logs on one side. So we're going to divide by log of 1.03. Now I know your instinct here is to pull out your calculator. Don't do it yet. Wait until the last step. You cannot round partway through because then your whole answer is going to be off. So you need to write down that you have 2x equals this fraction. And this is actually a pretty nice fraction compared to what we're going to see on Monday. Right, so that's pretty nice. How do I get x by itself? Divide by 2. So what you'll do is you're actually dividing this whole fraction by 2. So when we type this into our calculator, now you can pull out your calculator, you're going to take log of 2 divided by log of 1.03. So go ahead and do that, and you can hit enter after you get your answer. That's the first part. Now don't try to round that, don't try to retype it. Your calculator has that stored in there. Just hit now divided by, it'll steal the whole answer, 2, and then hit enter again. So let your calculator do all the work. Do not round until the very last step. And you get 11.725. Alright, we good so far on that one? Okay, so B, let's do the same thing. Can I find a common base here between 9 and 13? No, so we take the log again. So now x over 3 comes down, that's my exponent, times log of 9 is log of 13. What do I have to move next? Log of 9. So divide here by log of 9. And you'll have x over 3 equals that whole log fraction. Right. And then what you're going to do is you're going to multiply the whole right side by 3. So go ahead and type that into your calculator for me. Take log of 13 divided by log of 9, hit enter, and then do times 13. And tell me what you get. 3.5. 3 point what? 502? Okay. Alright, the next one's long. That's why there's no number problem underneath it. We're almost done with this. But the next one's a little harder, a little bit longer, so I gave you a little bit more space to work. 11 times 3 to the 2x minus 1. What do I start with here? Think about what you did in your quiz today. Divide by 11. I have to isolate the exponential before. So I have to get a number to a power by itself. So what that gives me when I divide is 3 to the 2x minus 1 equals 4. Now it's the same process to start. I take the log, which pops that whole exponent down. I'm going to write it in parentheses because it helps me remember that, like, I'm not moving the 2x or the 1 or anything until after I get rid of that log. And how do I have to get rid of the log here? I know you're shouting on the inside. You're dividing by log of 3. Now this one's going to get yucky. There's going to be more steps involved here. So I'm going to pull this up here. I have 2x minus 1 is log of 4 divided by log of 3. What do I have to do next to this? I'm not reaching for my calculator yet. What do I have to do? Plus 1. So I add the 1 here. And then I'm going to do it all in one step. Now what do I have to do? Then divide by 2. So I would divide all of that by 2. So when I put that in my calculator, you're going to do log of 4 divided by log of 3 and hit enter. Then what part are you going to do? Plus 1 and then hit enter again. And then divide by 2. So let's all make sure we get the same thing. Log of 4 divided by log of 3, hit enter. Plus 1, enter. Divide by 2. And did you get 1.131? All right. Okay, let's see what the last two are here. We can do D and E. Let's see. I don't think I'll do all of D, but let me start. What do you have to do first? Divide by 4. No, not divide by 4. Add 3. So we're going to start by adding 3. I won't do all the steps here, but I want to start you off. So we'll add 3. So then I have 4 times 2 to the x equals 20. And then what would I do? Then divide by 4. So we'll get 2 to the x equals 5. Is there a common base here? No. So you would go ahead and take the log of both sides. And is it okay if I leave that one? As one of my college professors, Dr. Tong, would say, leave it as an exercise for you. But that's okay. I want to do E, though. So let's do E. We'll do all of E. Okay, where do I start? Multiply by 2. Okay, so I multiply by 2. And can someone calculate for me what's 122.5 times 2? 245. Good. Okay. What do I do next? Divide by 5. And I get 7 to the x equals 49. What's my next step? I could do logarithm, but what's the easier way to do this? Common basis. So I have 7 to the x equals 7 to the second, and this is super fast. What's the answer? 2. There you go. So that saves it. That's a little faster. You could take the log, just a little bit more writing, a little bit more time. Okay? We good so far? Let's finish up here. We're going to talk about E. What do I do with E? Now, what do we know about the natural log of E? What does it equal? 1. Remember the other day we said if we take the natural log of E, because the base is E, equals 1. That's going to shortcut us in all of these problems. So we use the common log if we have any number. So all these problems up here, I use the common log because I just had 4, 2s, 3s. Down here, I'm going to use the natural log because I have an E. Only use the natural log when they give you an E. So what you do, the same logarithm law applies. So I'm going to take the natural log of both sides. Now the same rule applies, so I'll skip this step the next time. But that x comes in front, so you'll have x times the natural log of E. It's the natural log of 14. Now, what did we just say the natural log of E equals? 1. So this whole thing right here is just 1. Well, does that change x at all? Is x times 1? No, so all you have is x equals natural log of 14, and if you put that into your calculator, you'll get the answer. What is it? There you go. So see, like if you divide it by natural log of e, it wouldn't change your answer. It would just take more time. So which one do you want to do, B or C? C? Okay. Let's do C. So C here, what do I do first? Divide by 3. So I divide by 3 and I get e to the negative 5x equals 3. What kind of log do I take? The natural log. So when I take the natural log, that exponent comes down in front. And what happens in the natural log of e? I just cross off. B equals 1. So I don't have to do anything. I could divide, but that's just extra writing, extra work. I don't have to do if I recognize the natural log of e is 1. So what's my last step here? Divide by negative 5. So it's fine for me the natural log of 3 divided by negative 5. Get a negative.
Negative 22.
Yeah. Is it just 2, 0?
No, it's negative 0.220.
220. Okay. I'm trying to remember. We all got that? Okay. You understanding okay? So there's some practice at the bottom. I did